Now that we've looked at circles, we're going to continue with ellipses. Ellipses are ovals, so that means instead of having a constant radius, they have different distances in different directions. So the first thing, just like with a circle that we want to do, is identify the center. The center is in the numerator of my fractions. So for this one, my center is just origin, 0, 0. Once we identify our center, we want to plot that. Now we're going to do the square roots of the denominator. So square root of 25 equals 5, and the square root of 16 equals 4. So since the 5 is underneath the x, that means we're going to go 5 in the x direction from the center of my ellipse, which means in this one 5 to the left, 5 to the right. And then the 4 is below the y, so we're going to go up and down from center by 4 units. Once we have that, we can sketch our lovely ellipse. So since the horizontal direction is longer, that's called, the red points are called my vertices. So wherever the longest axis is are what you call vertices, so those would be at -5, 0, and 5, 0. Then we could use the other ones are my co-vertices, 0, 4, and 0, -4. That didn't ask for them, but that's what they're called. In this one, my major axis would be 10 units. My minor axis would be 8 units if we just count. I really don't like memorizing formulas in this unit because we can get there by just knowing a few things about square rooting the denominators and one more formula versus having to keep understanding a whole bunch of different ones. So now we're going to find the foci. To find the foci for an ellipse, we use c squared equals a squared minus b squared. These are just your a squared and b squared are from your denominator. I need it to be positive, so put the bigger number first. 25 minus 16. So c squared equals 9, so c equals 3. So to get my foci, you have to think, we'll start with both of these coordinates with my center. So I have 0, 0, and then 0, 0. And we have to look at what's changing. What is changing for my vertices? My x value is what changes between those 3 points. So my x value is where I'm going to add and subtract 3. So this would simplify for this one nicely. It would go down to 3, 0 and -3, 0, but I think that's the only one on this page that's nice, maybe. So this one we can graph. I'm not going to usually make you graph them because they're usually decimals. Okay, so those would be my foci. Looking at the next one, here we have a slightly more interesting center. So my center here would be 2, -1, so let's graph that first. Square root of 16 would be 4. Square root of 9 is 3. You're going to see a lot of the same numbers because otherwise they get really large really fast and get hard to graph. Okay, so that means we're going to go 4 to the right, 4 to the left from my center. Then we're going to go 3 up, 3 down from my center. Draw your beautiful ellipse. Okay, so once again, my vertices are the horizontal because that is going to be my longer axis. So we're just looking at our graph, -2, -1, and let's see, 6, -1. My co-vertices, I don't have room to write, would be these blue ones. Those are the co-vertices. And once again, you decide that based on what's longest, okay, not what comes first in the equation, which is what will be the situation with another one. Okay, now let's look at foci. So I have 2 foci. And we're going to write our coordinates for our center. 2, -1, 2, -1. And calculate c squared equals a squared minus b squared. Remember, a squared and b squared are your denominators, and it doesn't matter which one is which, just do it so it's positive. So I need it to be 16 minus 9. So c squared equals 7, and c equals the square root of 7. And what is changing? The x value is changing in those points, so it's going to be 2 plus square root of 7 and 2 minus square root of 7. See why I said we're not going to worry about graphing those? Now I want you to pause the video, try the next one on your own, and press play when you're ready to check. There you go. Now we're going to learn to complete the square to get to my conic form for an ellipse. So just like with circles, my first step is to get my x's by themselves and my y's, or x's together, y's together, and my constant to the other side. So 25x squared plus 150x plus 16y squared minus 160y equals -225. Now, what's different from last time is I don't have something that divides into all my terms. But what we're going to do is still split it up and look at the x's and y's separately. And now on the left side where I'm looking at my x's, those do have a GCF that I can take out of 25. It actually doesn't matter if it's a GCF or not. I take out what's in front of x squared. So that leaves me with x squared plus 6x. Then I'm going to do the same thing with the y's, plus 16 parentheses y squared minus 10y equals -225. Okay, and now I'm going to complete the square with this. How do we do that? So first of all, I'm going to go ahead and set up some things. I'm going to bring down this 25, bring down the 16, and then since I have a number in front of these parentheses, I'm not just going to add what's in the corner of my box. I'm going to be adding 25 times whatever's in my box, adding 16 and whatever's in my box. So I set up all of that at this step. Now we're going to complete the square like we did with circles or when we were finding the vertex. If you can start moving and not needing the box, that would be a great thing at this point. But if you still need it, it's there for you. Okay, so first term, first box, split in half. So 3x, x, 3, 3. So that's x plus 3 squared. What's in my gaping hole? 9. But I'm not just adding 9, I'm adding 25 times 9, because there's really that 25 in front. Okay. Now we're going to do y. Y squared, -5y, -5y, y, -5, -5. So we have y minus 5 squared. And what goes in my gaping hole there? 25. All right. Equals, now we're going to add up all that stuff on the calculator, which is 400. And now for ellipses, we need it to be equal to 1. So to make this equal to 1, I'm going to divide everything by 400. And then we're going to simplify. Now I'm going to be super nice to you, which means that the top is always going to be able to divide into the bottom. You're welcome. Okay, so when I do 400 divided by 25, I get 16. Then I have 400 divided by 16, I get 25. and that equals 1. And from there, it's like a problem on the front. So I'm just going to stop there, and we're going to be using this process just to make sure that we can complete the square. Okay, so now we're going to go to the problem on the right. Whee! All right, so first step, we get x's together and y's together. X squared minus 14x plus 9 y squared plus 36y equals, move the 49, negative 49. We're going to split it up. Now, I don't need to take anything out of my x side. I am going to think about that as a 1. So I'm going to come over here and put 1 times something just because I need to keep track of it. And then we'll complete the square with that. But on the right side, I need to take out the 9 from the y terms. I should have done this in a different color, but live and learn, y'all. Live and learn. So that's going to be plus 9, whatever I need to fill in for y. Alright, I'm really sad I didn't do this in color. We'll do it from color now on. Alright, x squared split in half, 7. X, negative 7, negative 7. So I get x minus 7 squared. Gaping hole for this one is 49. There we go. Then here I lied and I didn't do what I said I would do on the other one, which was set that up. First term, first box, split in half. Y, 2, 2. So y plus 2 squared. Gaping hole is 4. You like that? It's really that it's a square because this is completing the square. But if you ask most people why it's called completing the square, they have no idea. All right. So negative 49 plus 9 times 4 is going to give you 36. With ellipses, I need it equal to 1. So I'm going to divide everything by 36. So this first thing, there's not anything to do. It's just x minus 7 squared over 36 plus, now 9 goes into 36 4 times, so y plus 2 squared over, thinking, it's really hard, 4 equals 1. I want you to press pause and try the problems at the bottom. Here's the first one, second one. The last thing that we need to do is write equations given information. And the key to this is to graph it. Please, for the love of all that is holy, don't try to doing this without graphing. Okay, so this one has vertices at negative 8 and positive 8. So let's start there. What is equally between that? 0, 0. So that means my center is 0, 0, and I like to just go ahead and kind of start with my equation. I know I have a fraction, I know I have a y, I know I have a fraction, and it needs to equal 1. Because then I'm just kind of filling in the missing stuff for this. So I know that it's just going to be, because it's at 0, 0, it's just going to be x squared and y squared in the numerator. So that part's done, and I need my denominators. Okay, so how did we get our vertices from our equation? Well, for the major axis, we took this number 8 and we squared it because what was underneath was, in this case, 64, and we did the square root. This needs to go, since it's horizontal, it needs to go underneath the x. Not what's first, it goes underneath x. Then the next thing that they gave me is that the foci are at plus or minus 5. So that, if I graph that, from my center is a distance of 5, which means C equals 5. The formula that we use for foci for an ellipse is C squared equals A squared minus B squared. So my C, my focal length, is 5. Once again, that's because it's how far the foci are from the center. A squared is going to be 64, or we could put 8 squared, same thing, minus B squared. So 25 equals 64 minus b squared. And then we have, it would have been great if I brought my notes that had all of this done already. It would be wonderful. So b is going to equal the square root of 39. But what I need for the equation, I should have just left that, is b squared. Just kidding. Work smarter, not harder, y'all. Because to go in the equation, it's b squared. And then I'm done. So let's try another one. This one gives me vertices that are at 0, positive 5, 0, negative 5. Let's write my formula. X squared over something plus y squared over something equals 1. All right, so once again, my center of that is 0, so 0, 0, which you don't have to write. And this one is vertical. The distance from the center to a vertex is 5. So underneath the vertical variable, that would be y. It's going to be 5 squared, which is 25. Then it says that my minor axis has a length of 2. Okay? That means from the center, it's a total distance of 2. So what would be going each way? Going each way would just be 1. So the denominator underneath the horizontal variable is going to be 1 squared, which is 1. Okay? So to recap again, we graphed it. We see that it's vertical, so that means that the value I get here for 5 needs to go underneath the y, and then we cut the minor axis length in half to get how long I'm going to put underneath my x value. Last one, center is 4, negative 3. All right, let me write what my goal is. X squared fraction plus y squared fraction equals 1. They gave me my center is 4, 3, so x minus 4, y plus 3. And then I'm going to graph that. It's always a good start for negative 3. And I'm going to see if I can get away with this beautiful graph and not have to do something more particular. Okay, it says a major axis length 12 parallel to the y-axis. So think about x and y. Here's your y. So parallel to y is going to be a vertical line. Okay? Vertical. So if I think about it, if my whole axis is a length of 12, then going from the center to a vertex is going to be 6. So underneath, because it's vertical, underneath the vertical variable, y, we're going to put 6 squared. And then the minor axis is going sideways then. If that whole thing is 8, then half of it would be 4, so 4 squared. Then we can just simplify my numbers. X minus 4 squared over 16. Ooh, that was a bad 2. Plus y plus 3 squared over 36 equals 1.